Okay, let me continue, okay? So tell me, how could I answer those? So I'll do it again. So the point is, remember the rule I was trying to remind you. If we get the same base, we need to add up the exponent together, right?
Yeah.
So we got some factors. We need to use it. 4 to the power 2 and the 4 to the power 3, right?
Yeah.
So what is 4 to the power 2? It means 4 times 4. This one is kind of repeating.
Yeah, I know, 16. 16.
Yeah, okay. Let me write it. What is 4 to the power 3? 64, right?
64. Yeah.
Yeah, okay. So the point is, and instead of writing 64, this one could be replaced with 4 to the power 3, right?
Yep.
So let me write it. 4 to the power 3, and it keeps this exponent negative 2/3, right?
Mm-hmm.
Multiplied by 16, 16 it could be replaced with 4 to the power of.
Sorry? For part part two.
Yeah, right. Right?
Yeah.
Okay. I told you if you get, a couple powers, one of them is spin rate inside and the other one spin rate outside. What should I do? Am I supposed to add or multiply?
Multiply.
Yeah, good. So it end up with 5 to the power of
10.
You meant 6, right? Because 3 times 2, right?
Yeah, 6.
Yeah, okay. But what if you have got something else? Sounds like, no, let me try to make it sounds like a little bit harder. This one's going to be -3. So what should I do? I don't want you to get scared. This one's going to be the same, which makes sense. You have to apply the same thing, which makes sense. And -3 times 2. So what does it look like? So 5 to the power of
Negative 6.
yeah, multiplied by 5 to the power of 6, right? Whenever we
Yeah.
get, a negative power, we need to push it, to the lower part. So, you could write it just like 5 to the power of 6 over 5 to the power of 6. No, this one's been, it's been changed it because I swiped their places, right?
Yeah.
So you need to cancel each other out. So it end up with 1. Did you get it?
Yeah.
So here we have the same thing. So I need to multiply 3 times the negative 2/3. Don't worry. So 3 times the negative 2/3. What do you think? I need to cancel.
Wait,
we got 3 up and 3 down. So we'd end up with -2, right? Did you get it?
Yeah.
Okay. Or you
Can you
could
do that
write
again?
it like 3 times 2. So it's going to be -6 over 3 multiplied by 4 to the power 2, right?
Yeah.
Okay, and then -6 divided by 3. So this one's going to be 4 to the power of -2 multiplied by 4 to the power of 2, right?
Yeah.
So this one we need to keep it because the bar is positive. Well, we have an issue with the bar when the bar is negative. We need to swipe their places. This one was 4 to the power of -2 over 1. So you could write it just like 1 over 4 to the power of 2 multiplied by 4 to the power of 2. Or 1, we need to cancel the shares out, so it's going to be 1, right?
Yeah.
Okay. Or, and instead of doing all step, you could add up them together. So it's going to be 4, -2 plus 2. This one, it looks like 4 to the power of 0, which is supposed to be 1. Is it clear for you?
Yeah.
In all cases, they are the same. Okay. this one sounds like inequality, which makes sense whenever we get, the inequality, you have to read the head of question very carefully, because sometimes we graph it. But here he didn't ask me to graph it. Okay, so let me show you something. If we have
See if instead of showing me examples, can you show me how to do it so it's quicker so I can get all the questions done?
okay, in all if we got 5x minus 7 greater than or equals to 8, for example, this one sounds like inequality. You have to apply the same thing in both of equation and inequality. We have only one difference between them. In equation we got in the middle equal, but in inequality we have more than or equal or less than, right? So the first thing, I need to push I need to get rid of -7, which makes sense. I need to add up 7 to both sides, the left-hand side and right-hand side as well, right? So this one's been canceled. So 5x greater than or equals to 15, right? Where did you get 15?
Yeah.
Trying to add up those together. And then 7, so it's supposed to be 15. And then I need to divide each single side by 5. So this one by 5 and this one also by 5. So x greater than or equals to 3, right? If you want to graph it, if he asks you to graph it, this one, it looks like this one. We have the number line, and this one, it must be solid. You know why solid? Because we have an equal. If you don't have equal, so it's going to be like this one. And you have to go to the right, because I'm looking for all numbers, greater than 3. So I have to go to positive infinity, negative infinity. Did you get it?
Yeah.
Okay. But what if you have this one? Look at this one. This one's going to be a little bit different. If you have -5x, listen, in this case, you have to do all the steps. Like I need to add up 7 to both sides. So it's going to be -5x greater than or equals to 15, right? But in this case, I need to divide every single side by -5. Whenever you are trying to divide by -5, look at this one. This one must be changing. If it was more than, you need to turn it into less than, and vice versa. Did you get it? So less than or equals to -3. Why did you change it? Whenever we have the coefficient of x, it sounds like negative. And I try to divide every single side by negative. So you have to turn the more into less and the less into more. Is it clear for you?
Yeah.
Okay. So here we have a couple sides. I need to work out the left-hand side firstly. So it's going to be 5, right? I need to distribute -3 all over every single term inside the parentheses. So -3.
Yeah, -6.
Yeah, and then?
-9. Wait, +9.
+9, right. Okay, I have to do the same thing right over there.
6. Wait, I'm writing it down.
I need to bring down +6, right?
Yeah. Give me a minute. I'm writing it down.
Okay. I'm waiting for you.
Yep. I'm good.
Okay. So right now, I'm looking for the like terms together to be able to combine them together. Here we have 5 and 9, right? They're the same.
Yeah.
So let me write down -6x plus 14, right?
Yep.
Less than.
Sorry?
I was trying to add up 5 and 9, right?
Yeah, I know. Yeah.
Okay.
And
Here we
then
have 4x
plus 12.
Yeah, plus 12, right?
Yeah.
And then remember that I need to get rid of the smaller. I'm talking about the the variable. No, here we have -6 on the left hand side. On the right hand side, we get -4. So I need to get rid of -6. So it makes sense. I need to add up 6x to both sides, right?
Yeah.
This one's being cancelled. So here we have 14 less than or equals to 2x plus 12, right?
Yeah.
And then I'm trying to isolate x by itself, so it makes sense. I need to subtract 12 from both sides. So 2x greater than 2, right? Did you get it?
Yeah.
So, and then I need to divide the left-hand side and right-hand side by 2, so x greater than 1. And if you ask me to graph it, he didn't ask me. Here we have 1. We have open circle. Circle was open, and I have to go to the right. Because I'm looking for all numbers which meet up our constraint greater than 1. I'm looking for 2, 3, 4, etc. Did you get it?
Yeah. Wait, I'm copying it down.
Okay. Are you done?
Almost.
Yeah, okay.
I got it.
Yeah, okay. I still remember. I think no, it's not the last meeting. Probably for the last meeting, we discussed the irrational number, right? The point is, I told you that how could we simplify the irrational, right? Let me show you how. If you got something like,
I think I know how to do. I know how to do this one. I think. Yeah, I know
yeah,
how to do
okay,
this one.
yeah, okay. But the point is, the denominator. It looks like, I told you that all scientists were agreed. Whenever we have the denominator, we have an irrational. We need to get rid of it, right? So let me
Yeah, yeah.
remind. So if you get something
So
that sounds like,
75.
yeah, wait, hold on. If you have something like 3 over root 3, so I have an issue with the denominator. I need to handle it. I need to turn it into rational, right? So I need to
Yeah,
turn it into integer. So how can I do it? So I need to multiply up and down by root 3, right?
yeah,
Okay. So the first one looks like 3 root 3. Root 3 times root 3 is going to be 3, right? Did you get it?
yeah.
I need to cancel each other out. So you would end up with root 3. Did you get it?
Yeah.
Here we have the same thing. So how could I make a symbol? I'm looking for perfect
3 times
number.
25.
Yeah, good. 3 times 25. I need to highlight this one because this one looks like a perfect number, right? A perfect square number, right?
Yeah.
The other one sounds like 147, which makes sense. Oh, wait, hold on. This one sounds like 3 times 49,
Oh,
right?
yeah.
Both of these numbers are perfect, right?
Yeah.
So how can I do it? So 25, it's going to be
25
5
and 3. Oh, no,
root
5 and
3, right?
yeah.
Over, what about 49? 49,
7
yeah, looks perfect, square number, which is going to be 7
and 3.
root 3. I get the same thing up and down, which makes sense. I need to cancel each other out, right?
Yeah.
You would end up with 5/7. Did you get it?
Yeah, I get it.
Okay. Are you done?
Yeah.
Okay. Let me go over this one.
Yes.
Here we have the same thing, but expressed with the rational denominator. So I need to multiply by root 7 up. No, I root 7 down. Right?
Yeah.
So, and then it's going to be the first one sounds like 21 root 7 over 2 times. No, root 7 times root 7 is going to be 7. I told you that root 3 times root 3, it's going to be root 3. It's going to be 3. Where did you get 3? Because it's going to be root 9. And as you know, that root 9 is going to be 3 right now.
Yeah.
This one's kind of shortcut. So which makes sense. 21, I could divide both of the 21 and 7. So 21 divisible by 7. So it's going to be 3 up. So it looks like 3 root 7 over 2. Right?
Yeah.
Do it again or understand it?
Understand it.
Okay. Oh, listen. He asked me to turn it from being written into standard form into vertex form or canonical form. Honestly, I'm gonna teach you today a couple ways to do it, and both of them, pretty simple. You could pick up whenever you want. Okay, let me show you something. If he asked me to turn this one, for example, if I have f of x which equals to x squared minus 4 of x, and all of a sudden, I've been asked to turn it into the form of f of x which equals to a x minus h all to the power of 2 plus k. Whenever we get something like this one, it means that he wants from you to turn it from this form to another, right? Okay, the point is, I have a couple of ways to do it, honestly. I'm going to show you both of them, and you could pick up whenever you want. Okay, the first thing, what does it look like? This is called completing squares. This lesson is called completing square. It means that if we have something like this one, look at this one. What does it look like? Square, right? If I try to erase this part, it sounds like we get a message, right?
Yeah.
We need to complete it. We need to complete it to make it sound, it looks like square, right? This is the point that we need to do it. So if you try to take a look for this one, hold on. Okay, if you try to take a look for this one, it sounds like we get a binomial, right? Where's the third? We don't have the third, because if we have, for example, x squared minus 10x plus 25, this is called, a perfect square, which makes sense. And instead of writing this one, I could turn it. Looks like x minus 5 all to the power of 2, because I have a trinomial, 3 terms, right? But what if we have only 2 terms? How could I get the third one? This is the point. So we get a rule to be able to get the third. Listen, the third is going to be middle divided by 2 all to the power of 2. You have to memorize this one. Try to write down, okay?
Yeah.
So what is the middle? The middle, it sounds like the coefficient of x. So it looks like negative 10, right? But I don't care about the sign, because we have the bar is even. Whenever we have the bar is even, so remember that the negative will be cancel. So I don't care about it. But anyway, I'm going to write it. So it's going to be negative 10 over 2 bar 2, right?
Yeah.
So 10 divided 2, it's going to be 5, or negative 5 power 2. So it's going to be 25. Look at this one. So the missing term is 25. So what I want to do, just try to add up 25 and subtract 25. It sounds like I was trying to add up 0, right? Because 25 minus 25 is 0. So it doesn't affect, right?
Yep.
So it makes it, look at this one. This one is a perfect. Did you get it? So in this case, I have to open up only one bracket, all to the power 2, and you have to get the square of the first, so it's going to be x, and the square of the last, so it's going to be 5, and try to bring it down the sign of the middle, so it's going to be negative, right? And this one's going to be negative 25. You know, so I'm trying to ask you, what is the minimum or the maximum? You know, the parabola, if we have x squared is positive, so the parabola opens upward, right? Right?
Yeah.
So it means that I need to calculate the minimum, not the maximum. It makes sense because this one, it goes for, to positive, infinity. I wouldn't be able to determine the maximum. Let me show you what I mean. It was x squared minus 10x. Let me show you. X squared minus 10x. 10x. So look at this one. Do I have the ability to get the maximum? No, I wouldn't be able, right? But I have the ability to calculate the minimum. What is the minimum? What is the vertex? 5 and negative 25, right?
Yeah.
Okay, let me turn back to this one. So the rule tells us, if you ask me to calculate the vertex, change, keep. So if it was negative 5, I need to change it into positive 5 and to keep the outer one. Did you get it? If you ask me what is the minimum or the maximum, you have to tell him I need to figure out the minimum, not the maximum. Why? Because the coefficient of x squared is positive. Whenever we have the coefficient is positive, so I need to calculate the minimum, not the maximum. Did you get it? So the minimum is going to be y. So it's going to be negative 25. Did you get it?
Yeah.
Okay. Can we do it again?
I did the question, yeah.
Okay, x squared minus 4x. So how can I get it? How could I get it? I need to get the third one firstly.
Yeah.
So what is the first one? The third one, middle, divided 2 bar 2. So negative 4 divided 2 bar 2. Did you get it?
Yeah.
So how can
Negative. Oh no, negative 4.
No, it's supposed to be positive 4. Remember that the negative is being cancelled with the even power, right?
Yeah, yeah.
So positive 4 minus 4. It sounds like I was trying to add up 0, right? And this one's going to be bracket to the power 2. This one's going to be x minus, try to take the square root of 4. It's going to be 2 minus 4. You get it? What is the vertex?
2.
Change, keep. Negative 2. Yeah. I'm sorry. Positive 2. I'm sorry. My bad.
Yeah.
Positive 2 and negative 4. If you ask me what is the minimum, I need to back up the y. So the minimum point is negative 4. Did you get it?
Yeah.
Oh, we exceed 30 minutes. Okay. Let me continue. Okay. Did you get it?
Yeah.
But honestly, I have another way. I'm not quite sure if you'd like it or not, but I'm going to show you. This way, it helps us to get it. It looks much more easier, but this one depends on to keep a rule. This rule, it enables you to get it immediately. Let me show you. This one is called the canonical. Let me show you. So it sounds like a x plus b over 2a power 2 minus b squared minus 4ac over 4a. It looks hard, honestly, but if you have a really good memory, you would be able to do it in the same time, because this one it's going to be much more easier. Okay?
Yeah.
Okay. It was x squared minus, let me try it in both cases, okay? So the point is, listen, firstly, we need to determine A, B, and C. Let me show you something. The rule tells us ax squared plus bx plus c. So A, it sounds like the coefficient of x squared. And if you don't have anything, don't ever tell me 0. It's going to be 1. Okay?
Yeah.
So what A stands for? A is 1, right?
Yeah.
What is B?
6x.
No, it's wrong. You meant negative 6.
Minus 6.
Yeah. Okay. Please pay attention. Okay. What does C stands for?
8.
Good. This time, I need to apply the second method, because for me, it's going to be much more easier. Okay. But remember the rule. I'm going to show you the rule. Okay. A. And here we have x plus p over 2a all to the power 2 minus p squared minus 4ac over 4a. Okay?
Yeah.
So what a stands for is 1, right? I don't have to write it. So it's going to be x plus p over 2a, right?
Yeah.
X is negative 6. Let me use the parentheses. Divided by 2 times 1, all to the power 2. Get it?
Yeah.
Minus b squared. What is b? Negative 6 power 2, right?
Yep.
Minus 4 times a is 1. I don't have to write it. That's okay. Multiply by 8, right? Divided by 4 times a, it's going to be 1. Did you get it?
Yeah.
It sounds like this method, it depends on only substituting. Whenever you have the ability to keep the rule, you can do it immediately. It doesn't take time. Don't worry. This one, it doesn't depend on to get the third or something like this one, right?
Yeah.
Okay. So it sounds like x. Let me write the brackets. All to the power 2. Negative 6 divided by 2. Negative 6 divided 2.
Oh, right. I was writing it down. Negative 3.
Okay. So it's going to be negative 3, right?
Yeah.
Look at this one. So
I'm looking.
negative 6 squared is going to be 36, right?
Yeah.
Minus 4 times 8
32.
divided by,
4.
okay, look at this one. So it's going to be x minus 3 all to the power 2 minus 4 divided by 4. So it's going to be x minus 3 all to the power 2 minus 1. Did you get it?
Yeah.
Can you tell me how could I get the vertex? Change.
Change, keep.
So it's going to be 3n negative, right?
Yeah.
So I need to ask you a question.
Yeah.
Now, what if you have f of x equals to x squared? It looks like this one, right?
Yeah.
What if we have, so in this case, should I get maximum or minimum? What do you think?
Uh, mm, Minimum.
Yeah, you're right. What if we have the coefficient is negative? It looks like negative x squared. Should I get maximum or minimum? This one, in this case, it's always downward. It sounds like it's been reflected, right?
Mm-hmm.
So this one looks like max, no minimum. Did you get it?
Yeah, yeah.
So the point is, we got something. It looks like 3n negative 1, right?
Yeah.
So this one is called the vertex, right?
Yeah.
Did you get it?
Yeah.
Okay. I need to show you something. I need to, to match our solution with the graph. It was x squared minus 6x plus 8. Let me show you. X squared minus 8x. No, I meant 6x, right? Plus 8,
Yeah.
I think. Let me check. Minus 6x plus 8. Okay. Okay. So I'm looking for the vertex, right? Of the curve. This one. What does it look like? Sounds like 3n negative 1, right?
Yeah.
Did we get the same?
Sorry?
Did we get the same
Yeah, yeah.
or different?
Same.
Okay. The same, right? 3n negative 1. Did you get it?
Yeah, yeah.
So do you think that I have I got the minimum or the maximum? Maximum.
We got the minimum.
Yeah, right. Listen. This one sounds like order bear, right? 3n negative 1. I need to show you something. You know, what 3? I really care about 3. What does it mean? You know, 3, it sounds like the equation of axial symmetry. We get a line in the middle. So if you want to, divide this parabola into congruent parts, you have to use x equals to 3. So you will find that line in the middle, which cuts it into congruent. I know that probably didn't get well, but let me show you. If I try to write x equals to 3, so what happened? Could you describe to me what happened? So we get a line in the middle. This line sounds like it's been bisected into two congruent parts. So the left-hand side and the right-hand side, we get a couple parts. They are congruent to each other, right?
Yeah.
So remember that whenever we get this point, this ordered pair, 3n negative 1, remember that 3, the equation of axial symmetry. So if he asks you, what is the equation of axial symmetry? Remember that you have to tell him, sounds like 3. Remember, the equation of axial symmetry is always x, not y. And if you ask me to try to determine